recap, because I forgot to turn on the recording. We are looking at the Gaussian mixture model, and we discussed shortcomings of K-means algorithm, and then we have started looking at density estimation. Okay, so they help us in getting the distribution of data points. For example, if we have a blue uh, distribution, then the probability that you're going to get zero, or the probability of getting zero is given by this number here. Similarly, if you have a red distribution, and the probability of getting zero is given by the value over here. So as you can see, the area under the curve has to be 1 because it is the probability distribution. So if the standard deviation or variance is large, then your the height, the maximum height would decrease accordingly. Okay, so this is in case of 1D distribution. In case when you have 2D data points, then you're going to get a shape like this. ठीक है, इसमें क्या है कि and this is the equation of the Gaussian distribution, and again over here also it is defined or based on two parameters, defined by two parameters, mu and the variance. The mu in this case would be a two-dimensional vector denoting the okay, so this is the normal distribution. And now let's say the parameters, these mu and standard deviation, and I guess we were talking about this variance. Is this in case of 2D would be a 2 by 2 dimensional matrix. The first element here would denote the variance in this direction, The second diagonal would indicate the variance along the second dimension, and then these other off diagonal terms which will be equal because you are going to always get a symmetric covariance matrix. They denote the correlation between the two dimensions. So for example, in the case here, the variance in both dimensions is almost similar. So you're going to get maybe probably 1, 1 and 0, 0 because the shape of it depending on the shape of your Gaussian, you're going to get non-zero values here. So now let's say you are given these data points and you assume that your data has been generated by a Gaussian distribution given by this equation here. How do you compute the mean and the variance? That is the question because that will denote that will tell you कि center आपका cluster का क्या है and then the shape also. This covariance matrix is going to tell you the shape आपके जो cluster का shape किस तरह का है. So in case of a single cluster, we use maximum likelihood estimation (MLE), which gives us the mean and the covariance matrix. So in order to get the mean, we simply compute the average of all the data points. This is going to give us the mean, and in order to compute the variance, we're going to use this equation here. It is going to give us a 2 by 2 matrix, which is going to tell us the how our data points or what is the shape of you can say the cluster or the Gaussian distribution. आप इसको घर में जाके try to play with different values for the mean and for the covariance matrix, and then generate data based on that. For example, here the code is provided. Initially, this part is simply going to import the libraries that you are going to use. This part is going to then generate the data point. So for example, here I have specified that my covariance matrix is 0.8, 0.3, 0.3, 0.4. ठीक है, तो इसमें first so this is my covariance matrix, and then I generate random points I generate random point generated from a Gaussian distribution with mean at 0, 0 and the covariance matrix given by this matrix, and then I tell the function to generate 500 sample points. Okay, as a result it has generated these points over here. So you can see that the variance in this is more because here the number is 0.4 is bigger than 0.4, 0.8 is bigger than 0.4, so you have the variance is low in the second dimension. And secondly, this 0.3 is denoting कि आपका there is this the correlation between the first and the second axis is 0.3. If for example it was minus 0.3, then you would get a shape, something like that. Right now you're getting a shape which is like this. Okay, and now यहाँ तक तो आपने लेट्स से कि डाटा जनरेट कर लिया है. लेट्स अज्यूम कि आपको नहीं पता कि व्हाट इज द वेरिएंस कोवेरियंस मैट्रिक्स, एंड सेकेंडली नीदर डू यू नो कि इसका मीन क्या है. ठीक है, यहाँ तो हमने स्पेसिफाई किया था जनरेट करने के लिए. सो ऑल यू आर गिवन इज दिस एक्स और ऑल यू गिवन इज द डाटा पॉइंट. हाउ डू यू कंप्यूट द मीन एंड कोवेरियंस मैट्रिक्स यूजिंग मैक्सिमम लाइक्लीहुड अप्रोच. जो पिछली स्लाइड पे हमने मेंशन किया है, इन दो इक्वेशंस को आप यूज़ करके मीन वेक्टर जो उसका मीन लोकेशन है और उसकी जो कोवेरियंस है मैट्रिक्स वो कंप्यूट कर सकते हैं. यूजिंग sklearn it is very easy. You simply call this function and it is going to compute those. और यहाँ मैंने वो वैल्यूज प्रिंट की हैं. तो दिस इज योर covariance and this is your mean, and you can see they are very close to the actual value that we had. Yahan this is 0.75 and actually it is 0.8, So this estimation is quite accurate. So this is the maximum likelihood estimation technique to find the mean and covariance of a single cluster, assuming that the cluster was generated by a Gaussian distribution. So this is the assumption that we will be making throughout. चूंकि इस लेक्चर का टॉपिक भी Gaussian mixture model है, तो we will always be assuming कि जो आपके जितने भी clusters हैं, they are generated by a Gaussian distribution. So all we need to do is to find the parameters of that Gaussian distribution. So single clusters है very easy to find the parameters using maximum likelihood estimate. Okay, now next we will move on to the case when you have multiple clusters. So these are multiple clusters, 3 here. Now, how do you compute the naturally we said कि जितने भी clusters हैं we have assumed कि वो एक Gaussian distribution जो है it has generated those sample points. So there is mu1 corresponding to the first cluster or the data points which generated or the Gaussian distribution which generated these data points. Similarly, mu2 sigma 2 and mu3 sigma 3. Sigma 3. तो ये 6 parameters आपको पता हो तो then the job is easy. You can easily compute the overall probability. But the thing is that you do not know कि पहली बात तो ये है कि you do not know कि ये points हैं वो किस cluster से belong करते हैं. यहाँ तो different color में drawn है shown yellow, purple और green में. So it is easy to see that there are 3 clusters. However, you are given just random some data points and you do not have any class labels. So your job is to find the clusters and basically which means कि आपने ये सब चीजें find करनी है mu and the sigma. So how do you do that? The first thing is that we now need to define our probability. In a single cluster case, the probability was defined by this equation over here. By this equation, probability of x equals to this, or let me write it over here. In a single cluster case, इस तरीके से आप probability find कर लेते हैं किसी भी data point की और belonging to that cluster. और in general Gaussian distribution की बात करें तो this equation is going to tell you what is the probability of getting this data point x. तो ये तो था for single cluster. If you have multiple clusters, then of course we need to do something else now. What we need to do is कि हमने अब let's say कि ये आपके पास 3 clusters हैं, तो हमने अभी इसको modify करना है. So the probability x will no longer be simply 1. इसकी तो अभी नहीं हो सकती क्योंकि we have now 3 different clusters. So what we're going to do is we're going to have now a mixture of Gaussian. K, small k will go from 1 to 3 and then so this is going to define a mixture of Gaussian. कि अगर 3 आपके पास clusters हैं तो we are going to use the 3 Gaussian distribution और उनको ऐड करेंगे. Then of course we have to make sure कि आपकी जब probability should sum to 1, ऐसा नहीं होना चाहिए कि वो probability 1 से ज़्यादा हो जाए. So if you simply add them तो वो आपकी probability ज़्यादा हो जाएगी, right? क्योंकि the probability अगर let's say हम इस data point की बात करें तो this equation is telling us कि हमने इसकी probability find करनी है by computing the probability that it belongs to this, the probability that it belongs to this cluster and the probability that it belongs to this cluster. तो maybe इस cluster को belong करने की probability हो yeah, let's look at some other point. Okay, maybe a point over here. ठीक है, let's look at this point. So इसकी probability that it belongs to this cluster may be 0.7. The probability that it belongs to this cluster maybe it is 0.1, and the probability that it belongs to this cluster maybe 0.3. I'm just giving example. तो इन सब probabilities को आप add करेंगे तो 0.7 plus 0.3 plus 0.1 it will become 1.1. which is more, probability becomes bigger than 1. We don't want that. So that is why we also need to multiply it with another uh, this parameter, which is going to also tell us, okay, what is the probability of these three of occurrence of these three clusters, right? And we are going to make sure that just the sum 1 plus 2 plus 3 should be equal to 1. तो ये हमें make sure करना है. By doing that, basically what we are doing is कि अब अगर हम इसको अगर ये हम ensure करते हैं, then no matter what these probabilities are, eventually you're going to get a sum which is, uh, which will not be bigger than 1. Okay. So this is our model now. ये हम use करेंगे. This is the Gaussian mixture model. So a Gaussian mixture model represents a distribution given by this equation over here. And we have now, if we look at this example, we have 9 parameters of this distribution. How 9? एक तो आपके पास pi 1 आ गया, then you have mu 1, then you have sigma 1, similarly pi 2, mu 2, sigma 2, pi 3, mu 3, and sigma 3. Okay, so if you know all these 9 values, then you can easily compute the probability of any of these data points. For example, if you want to compute the probability of this data point, you can use all these values to compute the probability. Okay, what is the probability of getting this data point? So these the pi parameters, इसको हम कहेंगे mixing coefficients. Okay, so this is a special name for that. These values are the mixing coefficient, because they are telling us कि किस लिहाज से आपने mix करना है. Mix means कि if if let's say one cluster has, in this case it appears that all the three clusters have equal number of data points, all around the same number of data points, but it may happen that you may have one cluster in which your data points are very less. So in that case, the pi belonging to that cluster, the mixing coefficient would have a smaller value, and if there are more data points, then your mixing coefficient would have a bigger value. But if you take the sum of all these mixing coefficients, it should sum to 1, as mentioned over here also. Okay, any question up till now? So what is the objective now? The objective is to find these 9 parameters, or I mean, यहाँ तो 19 clusters हैं, अगर 4 clusters होंगे तो 12 parameters and so on. So this is the objective. So the Gaussian mixture model, if we talk about the Gaussian mixture model, it is simply this equation over here, जो हमने कहा कि we're going to use the mixture of Gaussian. पहले हमने start किया by looking at one cluster, और हमने कहा कि ये जो data points generate हुए हैं, they are generated by a Gaussian distribution. We assumed that. And the objective now is to find the mean and the variance or covariance. With that, we can easily compute the probability. And we use maximum likelihood estimation technique when we were talking about one single cluster. However, when we're talking about multiple clusters, we cannot use maximum likelihood estimation technique, because that is only for single cluster. So what we're going to use is the algorithm expectation maximization. So this algorithm is going to help us actually estimate these parameters of this Gaussian mixture model. Okay. So before going that, let's also look at an alternative view of the Gaussian mixture model. So alternative view क्या है कि so if you have to just remember, or so when we're talking about the naive Bayes, we had this figure like that. Or when we're talking about the Bayes theorem, we had a figure like that. कि आपके पास this is a random variable which we said is unobserved, or we can also call it hidden. Or in case of today's lecture, we can call it the latent variable. and this is the observable variable. So this is latent and this is x is observable. So when you are given data points, for example, these are your data points. So we are calling these data points your, your x, and so this z is another variable which is not observable, but the data points, these data points जो आपके generate हुए हैं, sorry, these ones, they are dependent on the on the on z. Okay, so now how they are dependent, या किस तरीके से हम इसको हम कह रहे हैं. The thing is कि if we have 3 clusters, then this variable z is telling us कि data point जो है वो कौन से cluster से belong करता है. And once we know कि वो cluster से belong करता है, then we have the likelihood probabilities basically के given by these normal distribution, so we can easily compute that. In case of clustering, we are not given के कौन से जो data points हैं आपके पास वो कौन से cluster से belong करते हैं, right? ये आपको सिर्फ x given है, but z is not given, which is latent variable. Z tells you कि ये data point हैं, ये सब एक cluster से belong करते हैं, ये दूसरे cluster से belong करते हैं, ये सब तीसरे cluster से belong करते हैं. So this information is not given to you, but you can still model it like this. Okay, x is our observable variable, z is the latent variable, and x basically, there's this dependence relationship between this x and z. Now, in case of naive Bayes, if you remember, this probability was called the likelihood probability, and similarly this probability was called the posterior probability, and the objective was to find this posterior probability. Now the objective in this current clustering, the objective is to find the probability of x, right? कि आपके जो data points हैं उसकी probability क्या है. तो we can actually, let me go to the that lecture actually, the naive Bayes lecture. इसमें if you remember के we had these two rules, the sum rule and the तो यहाँ आपके पास था एक sum rule था और एक product rule था. The sum rule is this कि अगर आपने marginal compute करनी है तो ये first जो sum rule है, it is marginal. If you want to compute the marginal, this is how you're going to compute that. So here also we want to find the probability of x. We can use this equation. So basically तो यहाँ आप देखें तो exactly वही equation हम लिखी है कि से variable का नाम change है, वहाँ y है, यहाँ z है, but other than that we are using that equation. And probability of x y है in the product rule, it is computed by you can write this equation जो bottom पे second rule है उसके मदद से आप joint probability लिख सकते हैं. तो exactly वही हमने ये किया कि we have used that product rule to compute the probability. So in order to compute the probability of x, we have this equation. ठीक है, ये सिंपल हमने जो बेस थ्योरम केस और नाइव बेस में जो हमने पढ़े थे फॉर्मूलाज, उनको यूज़ करते हुए वी हैव कंप्यूटेड कि अगर आपने प्रोबेबिलिटी ऑफ एक्स निकालनी है तो वो इस इक्वेशन से आ जाएगी. नाउ वी ऑलरेडी हैव, देखिए हमने पिछली स्लाइड में ऑलरेडी हमने जो प्रोबेबिलिटी ऑफ एक्स का ये इक्वेशन फाइंड कर चुके हैं यूजिंग द गॉसियन मिक्सचर मॉडल, तो विच इज़ रिटन हेयर ऑल्सो. तो ऑल वी आर डूइंग हेयर इज इक्वेटिंग दीज टू. इक्वेटिंग क्योंकि यहाँ भी probability of x है, this is also probability of x, so this equation is equal to this equation. ठीक है, तो अभी the thing is कि now we want to see कि how these आपके पास individual components हैं, this one and this one, ये इस जो गॉसियन मिक्सचर मॉडल में जो डिफरेंट आपके पास कंपोनेंट्स हैं वो किस कौन सा कंपोनेंट किस टर्म को डिनोट करता है। तो वो इस तरह है कि दिस इज अ लाइक्लीहुड प्रोबेबिलिटी एंड दिस इज गिवन बाय दिस इक्वेशन ओवर हियर, ये जो आपकी नॉर्मल डिस्ट्रीब्यूशन है, एंड दिस इज द प्रायर व्हिच इज गिवन by the mixing coefficient. So the mixing coefficient is basically telling you okay, what is the probability uh, of these three different clusters. ठीक है, जैसे मैंने पहले कहा कि अगर आपके पास ओके तो so this slide simply gives you an alternative view कि अगर आप इसको using a generative view अगर इसको देखना चाहें तो this is how you arrive at the equation, or this is how you understand it कि basically this is what you're computing. टाइम जो है वो ऑलमोस्ट खत्म हो चुका है, तो आई थिंक आई विल नॉट गो एनी फर्दर. What remains is the expectation maximization algorithm. वो भी हम डिटेल में नहीं जाएंगे. We are going to look at a very abstract level, maybe next class. और हाँ, तो it probably 10 it will require 10 more minutes. So any question up till now? To summarize what we did today, we looked at shortcomings के k-means algorithm जो हमने इससे पिछले टॉपिक में लेक्चर में पढ़ा था कि वो क्लस्टरिंग एल्गोरिथम था. इट गेव अस अनसुपरवाइज्ड एल्गोरिथम था, क्लस्टरिंग एल्गोरिथम था. इट गेव गिवन डेटा सेट. k-means एल्गोरिथम हेल्प्स इन क्लस्टरिंग और ग्रुपिंग आवर डेटा पॉइंट्स. लेकिन उसमें जो प्रॉब्लम हमने डिस्कस किया या दो शॉर्ट कमिंग्स वो ये थी कि जो आपकी ग्रुपिंग होती है इट इज़ हार्ड ग्रुपिंग. ईच डेटा पॉइंट इज असाइंड टू वन ऑफ द डिफरेंट क्लस्टर्स दैट यू हैव. एक तो ये प्रॉब्लम है. दूसरा ये है कि यू लैक अ प्रोबेबिलिस्टिक असाइनमेंट. सॉरी, वो तो चलो हमने बात हार्ड में बात कर ली. सेकेंड प्रॉब्लम इज के यू हैव ए स्फेरिकल क्लस्टर. ठीक है, के मींस एल्गोरिथम में you get spherical clusters. Points आपका elliptical, तो secondly it also gives you elliptic shape clusters. और elliptical हमने जैसे डिस्कस किया वो किस तरीके से आएंगे, जैसे हमने बात की कि the Gaussian distribution है. Gaussian distribution basically is denoted by, or it has two parameters. एक तो mean है और second is its covariance. The mean तो cluster का center है जो mean लेकिन इसमें एक एडिशनल वेरिएबल है, इस प्रॉब्लम में भी देखा था. डिपेंडिंग ऑन दीज वैल्यूज यू आर गोइंग टू गेट डिफरेंट शेप. सो प्लीज ट्राई टू प्ले with different values, or तो किसी मतलब by changing the values you can get different shape clusters. और उनका मीन भी अगर चेंज करें तो the mean will also change. So this is the difference between k-means and the Gaussian mixture model. कि यहाँ आपके पास दोनों एक तो मीन तो है जो कि k-means में भी था, लेकिन अभी आपके पास एक कोवेरियंस मैट्रिक्स भी है which tells you कि शेप आपके क्लस्टर कैसे है. ठीक है, तो उसके बाद हमने कहा कि अगर एक ही क्लस्टर है तो उसमें तो बड़ा आसानी से यूजिंग दी इक्वेशन हम कंप्यूट कर सकते हैं द मीन एंड द शेप और दिस कोवेरियंस by using maximum likelihood estimation technique, which simply is using these two equations. ठीक है, लेकिन दिस इज ओनली एप्लीकेबल जब आपके पास अगर एक क्लस्टर है, मल्टीपल क्लस्टर्स हैं तो दिस इज नॉट गोइंग टू हेल्प यू। उसके लिए वी आर गोइंग टू यूज एक्सपेक्टेशन मैक्सिमाइजेशन एल्गोरिथम, जो कि हम नेक्स्ट क्लास में पढ़ेंगे। तो दैट्स ऑल। एनी क्वेश्चन? लेट मी टेक द अटेंडेंस। अटेंडेंस तो उसमें आवाज़ ही नहीं आएगी मुझे।